Hello, and welcome to Securing Data with InterBase. This webinar on securing data with InterBase will cover the encryption methods that InterBase uses to help you secure your data. My name is Mary Kelly, and I'm a software consultant and InterBase enthusiast here at Embarcadero. Now, on our agenda today, we have a lot to discuss to see how InterBase helps you to protect both yourself and your customers from data exposure. We'll discuss why database security is so important today, some of the consequences and challenges we tend to face in ensuring our data is protected, and how InterBase encryption works to help ease and solve some of those problems. Databases are vital in today's organizations. They really are everywhere you turn, collecting more and more information about the backbone to your company. They manage your customers, employees' info, transactions, financial data, and even more. And as application or database developers, DBAs, security officers, it's our responsibility to make sure that this technology that everyone relies so heavily upon is protected from malicious, unauthorized access. One of the most important aspects of database security is the confidentiality of your customers and your customers' data. It's a never-ending process of regulations, policies, and laws that are heavily enforced by every industry and many countries. Healthcare has HIPAA, which sets the boundaries for the release of electronic healthcare records. If you're found non-compliant for neglect, the violations alone could cost you up to $1.5 million each year for not correcting within a time period. In finance, you have the GLBA that requires that institutions explain how data is shared with third parties and amongst themselves, requiring that you have an opt-out option along with user privileges access and ensuring that all data is tracked, including unauthorized access attempts. You have PCI for ensuring that all companies that accept credit card information maintain a very secure environment. FERPA for the protection of students' data. And GDPR as of May 25th, 2018, providing the guidelines for collecting and processing personal identifiable information for European Union citizens. These regulations give us the guidelines and in many cases some best practices that we can implement to allow us to maintain our customers' privacy and normal business operations. When it comes to consequences relating to data breaches, we tend not to need look further than the news. In recent years, we've had several major data breaches that have stolen credit card information, patient data, like names, social security numbers, financial account numbers, and so much more. The number on how many individuals' information is stolen is staggering. But maybe it's not just customer information that's been stolen, but your organization's business operations and information that's been compromised, having to halt business, bringing in consultants, running a whole bunch of tests, and working with other security vendors as well as dealing with lawyers and also managing pending lawsuits. The cost of having to notify the proper regulatory committees, and as well as finding ways to communicate with all of your customers to bring awareness. Emails, maybe a dedicated site on responses, or perhaps just having an influx of customers hitting your servers all at once to change passwords or alter data in an attempt to further protect themselves. But it's not only the cost of fines that affect organizations who don't secure their data. The damage to the reputation of a company who fails to protect personal data can take years to build back up, if it's even possible at all. Some of the challenges that come with database security, especially as we move to the cloud or to mobile storage solutions, include needing to consider where the data is located. For example, is it on the LAN? Is it located on a removable disk as a backup? Maybe you're producing mobile applications with embedded solutions. The location of data will often determine the type of processes and the measures that you will use to secure that information. Many organizations have to make sure that they have the appropriate security measures in place on all their devices, smartphones, PCs, that will be accessing the stored data. And this is a challenge as these mobile devices, these PCs, these endpoints, can otherwise be a weak point in your organization's security defenses. How are you managing data security? Over the wire encryption? So now you have the network traffic that you have to start monitoring and worrying about for all data with all end users. On disk, are you set up with full disk encryption or just file encryption? And how are you managing your security if you're in a distributed environment? Access control. A must-have is a role-based access control for secure data storage. And in many cases, you may even have to add a multi-factor or a multi-layer authentication. Administrators also have to be sure to change any default passwords on their storage devices and to enforce the usage of strong passwords by their end users. Data quality. With analytics, we have so much more awareness than ever before on the value of data. But in order for data to prove useful, enterprises need to be able to ensure the veracity of their data, and that means investing in security. The challenge here can come in the form of too much data, or perhaps duplication of data, compliance issues, especially when we look at contact information. Contact info rarely stays the same for an extended period of time. People move, change their names, and this results in duplicate records and or obsolete data. Without constant verification, you could be leaving yourself open to unauthorized individuals gaining access to confidential information, all because of a simple miscommunication. And of course, confidentiality. Privacy. What data can be considered public, and what's the level of value for each of our data classifications? We know the difference between public knowledge and highly sensitive data, like social security numbers or credit card numbers. And we know that every system or solution can have some vulnerabilities, leading to privacy threats. So, privacy and integrity of our data once it's been entered can be a challenge with fully implementing security plans. We know it's a good idea to figure out some of the answers to your security questions before getting started, and encryption specs are really no different. Where is your sensitive data located? Is it in some remote site room that's fireproof, axe-proof, and has a backup generator the size of your house? Maybe you're choosing cloud storage for distributed coverage worldwide, or looking for something that can sit on a phone or a tablet that your customers and employees need access to. What are you doing to make sure that that data isn't exposed? Third party, built in? Who has access to that data and how are they accessing it? How are your users set up for access? Are we in compliance with our industry's regulations? Who holds responsibility for your data management? Are you still meeting your business requirements? The questions can be long and overwhelming, and the answers can be even more exhaustive. So let's take a look at how InterBase works to help you answer those questions. In general, security for InterBase relies on a central security database for each server host. This database, also called the admin.ib by default, contains a record for each user who has permission to connect to the databases and the services on the InterBase host server. So each of these records includes the user login name and the associated encrypted password. User security is a very important yet complicated topic in database security. A large majority of applications that store data need to have different levels of access to that data. And while building those requirements for your solution, you have to determine who should be seeing what data is in your database. From there, you can identify the common roles that your users are needing access to. And when a user or multiple roles have been defined and have been granted privileges, you can then grant that role to one or more users who then acquire all the privileges that have been assigned to that role. So the idea behind user security is controlling who gets to see what data and what purpose they have for seeing that data. It's important to understand who exactly should have access to the data. And what InterBase provides with role-based user security is that you're putting these roles or these groups into your data layer. So you're adding some additional safeguards for abuse of privileges by users. In InterBase, there are two key users that you should be aware of. The database owner, typically your sysdba, who can grant access and is basically your administrative InterBase user with exclusive rights. Now, only the sysdba user can update the security database to add, delete, or modify user configurations. And the sysdba can either use the command line gsec or IB console to authorize a new user by assigning them a specific username and password. And your second user is the sysdso, your System Data Security Officer or owner. InterBase security can also either be embedded inside the database, or you can use the admin.ib file. By using admin.ib, it can run across multiple databases. And if you want the security to be specific to one database, then you can use the embedded version of InterBase, where the security table is inside the database. So this is especially useful for mobile devices, as the database itself can't be used or accessed outside the application accessing the credentials. Now, you could always set up user security on every individual user. Say you have access to update this and that table, or since you're in this management position, you can see your employees' logged hours. But by creating and defining roles, then having users grouped into those roles, it makes it a lot easier to manage your database security because of the boundaries set for that role and the time saving for your IT department. They won't have access rights to roles other than the ones they're assigned to, making it easy to add or remove access to data across your entire system. Encryption introduces a special user known as sysdso, like sysdba. Only sysdso is the System Data Security owner and owns the responsibility for many of the encryption-related activities. there is, by design, a separation of power between the database owner and the SysDSO, which is designed to help facilitate secure practices. The SysDSO role controls three significant steps in the encryption process. The SysDSO creates a system encryption password, or an SEP. They also create the encryption keys and grants the database owner access to the encryption keys, which he or she can then use to encrypt the database and the columns. However, the SysDSO can't actually encrypt databases or columns, nor can he or she grant or revoke access to encrypted data. Only a database owner or an individual table owner can actually encrypt a database or the columns. The SysDSO really just creates the tools, in this case the encryption keys, that are needed to perform the encryption. So this requires that we have multiple users set up to correctly implement encryption, rather than just one person holding all the power. And this really just adds an additional layer to your database security. Using role-based security and having a separate security user in combination with our next topic, InterBase encryption, provides a solid foundation for protecting your data and your users. Before I get started on talking about some of the ways that InterBase uses encryption to protect your data, I'm going to go ahead and show you how to quickly create your DSO user, as well as creating a few users and a role. We'll start out by creating our SysDSO user. So I'll right-click in the Users pane and go to Create. I will create my SysDSO. Now, SysDSO is a reserved word in InterBase, so you can only use it for this type of user. I'll create a password, any password that you want to use, and I'm going to go ahead and leave all of the rest of these descriptors blank. I'll fill in my first name, MT Kelly, and I'm marked as active. So I've now created my SysDSO user. Next, I'm going to create two additional users. So I'll right-click again and go through the same process as I did to create my SysDSO. I'll name this one MTK and add in a password. Still set as active. And I'll create my second user. This one will be M. Kelly with a similar password. Now I can also create users not only in IB Console by just right-clicking and creating new users, but I can also go into Interactive SQL or iSQL and create those users by using some SQL code. Now that I have two additional users along with my SysDBA or database owner and my SysDSO in my pre-encrypted database, I can go and look at some roles and user permissions that I already have in place. So right now I already have one role, which is admin, that's owned by the SysDBA, and the only person that has access admin option and is a member of this specific role is my user MT Kelly. Now I can go and add additional members if I choose to, or leave it as is. If I want to create a new role, I right-click and create. I'll say generic for this one, and the owner will be the same person listed in my admin role. This will be my SysDBA, as this is the database owner. and I will add the same user mtkelly for my generic role. And I'm not going to grant admin option. Admin option is just the ability to grant roles to others. So I'll click OK. And as simple as that, I've now created a role. Now, this generic role does nothing at the moment. It's got a single user, but it doesn't have any functionality. It doesn't say you're encrypted or you're not encrypted for these specific columns or these tables. To provide some functionality to this specific role, if I double click on generic or go to admin, then I can see that for either one, admin or generic, mtkelly is my only user. Now up here at the top I've got these three tabs: properties, metadata, and permissions. If I click on permissions, then right now, showing permissions on, I currently only have that mtkelly is a member of my admin role with grant option. If I click on show permissions for, then I currently have no objects that admin has access to. So to provide mtkelly, or to provide the admin role with some functionality, whether it's to decrypt certain information or just to be able to update information or delete, then I can go and I can create any of these object types, either executing a procedure, viewing tables, or views. If I want to see specifically in admin customer information, so I say, all right, I'm giving permission on the customer table for the administrative role or admin role. Since it is admin, admin has full privileges for everything and does in fact have grant option. So this specific user within role admin will have all options available. So from there, I have added that this specific user from this specific role now has permissions on the customer table. So mtkelly within this role now has permission for the customer table, whether it be accessing the select, delete, insert, update, reference, and decrypt commands. If I would like to say that this certain user can execute a specific procedure, I say the department budget, then I can click here and say that my permission on the department budget stored procedure for execution by admin is okay, it's good. Click OK, and now I now have permissions for the customer table and the department budget to be executed by this specific role. InterBase supports several ways to encrypt data. You have data at rest encryption with both DES and strong AES 256-bit encryption. And this literally means that when the data is not being used, when it's just sitting there and your application is inactive or off, the data that's stored on the device is still encrypted at the same level of encryption as when your application was open and accessing the files. This is a particularly popular feature amongst mobile developers for storing data, as many attackers find that data at rest is a far more valuable target than data in motion. Being able to specify what information is encrypted with database and column level encryption, having a separate security user like the sysdso, as we described earlier, using roles or groups to determine who has access to what data, between servers and clients with over-the-wire network encryption, and by encrypting your backup files that may be stored for historical records. InterBase encryption is built into the database as part of its cross-platform single file format, which allows InterBase to offer protection for your data everywhere that it's located throughout your entire software development lifecycle on whatever the device. Since it's the same database file that you're using on your server, that you use in your iOS or Android application, that encryption moves with you on the server and on those devices. Now, InterBase has support for both AES and DES encryption algorithms. There is DES, or Data Encryption Standard, which is your 56-bit weak encryption, and AES encryption, or Advanced Encryption Standard, and this is your strong encryption, and InterBase provides 128, 192, and 256-bit levels of AES encryption. Both DES and AES encryption are actually built in or included with your InterBase licenses. So out of the box, you can set up an encrypted database without a lot of hassle. So for this example, I'll be using IB Console and a pharmacy database from a sample application. After connecting to the database, there is an action item called Encrypt Database. So double click and it brings up the database encryption wizard. This wizard guides you through encryption key creation, which can be used to bring about database level encryption on this database. The first step is to provide the sysdso password. This is the system data security owner that I mentioned earlier. This person is responsible for creating the encryption keys, and then we can establish a system encryption password, or SEP, then specify a name and options for the encryption key, and last but not least, get a backup key. Click Next and we can provide the sysdso password, whatever you have set it to. Now we can choose the encryption password of our choice and then confirm that password. Now I also have the option to check the external checkbox if I don't want the SEP to be associated with my computer. So the SEP protects the encryption keys that are used to encrypt my database and the columns. I'm only using database level encryption, so I will title it as such, as well as make it my default key and use case sensitive name. I'll go ahead and choose AES strong encryption at 256-bit key length with both init vector and padding set to random. This gives me the highest level of security and doesn't provide any clues to figuring out my data. So now I'm going to create a backup key with my password and confirm that password again. Then click OK, and at this point my database is encrypted. So now that my database has top-notch encryption, I can open it up in Notepad, and as you can see, the data is a bit more cryptic and far less recognizable. InterBase has two levels of encryption: database and column level encryption. For database level encryption, InterBase encrypts all the database pages that have user information. Non-user information that's stored in database pages is not encrypted and include things like the header page, log, and inventory pages. So you encrypt the entire database using an encryption key. With column level encryption, you can be far more flexible and even more specific. When you encrypt a column, you specify the table that contains that specific column. Now, you can choose to either encrypt all the columns in that table or only the columns that you want. For example, in your database, you have an employees table with a payroll column that both payroll and human resources need access to. Then you have a Social Security numbers column associated in that table that human resources doesn't need access to, but payroll does. You can encrypt that Social Security column so that only your payroll employees or other users who need access to that specific data in those encrypted columns can be given decrypt privileges for that column. So here in IB Console, I'm currently connected to my employees database under SysDBA. So I'm going to go ahead and click on tables and go into my employees table. Now here I have access to the salary, and at the current moment it's not encrypted. So what we're going to do is encrypt this column. And there are two ways to encrypt this column. You can either click here at Edit Field or just right click after highlighting and edit the field itself. Now, because my database has been encrypted, I now have access to encryption and then my decrypt default. So for encryption, I'm going to choose column level key. And for my decrypt default, I'm going to choose 0. So if I don't have decrypt permissions, I'll see 0. I'll click OK. Click OK again, and you can now see that my column salary in my employees table now has my column level key encryption. Now this encryption key has 256-bit AES encryption, and click here on permissions. Now I already have a user named Mary Kelly, so I'll go in and double click on that user and I'll pull up the grant editor. So the grant editor is just allowing me to determine what privileges that Mary Kelly, my user, is allowed to have. So right now I have decrypt, and I want to decrypt the salary column, so I'll add that. Okay, so now Mary Kelly, decrypt on salary. Now Mary Kelly is going to be my user that can access or decrypt my salary. So I'm gonna go and create another user real quick. Create, this one will be M. Kelly, and it'll be a pretty simple password there. So now I've created this new user. Now I'm going to go ahead and disconnect from my database, and then I'm going to log in as Mary Kelly and put in that password. So I'm now connected as Mary Kelly to the database. Now if I go up to Interactive SQL, I can say select full name and salary from employee, and if I execute that, then Mary Kelly has the ability to decrypt that specific data. No, I do not want to roll back. Now I'll disconnect from Mary Kelly, and then what I'll do is connect as, instead of Mary Kelly, that new user that I created, M. Kelly, with that very simple password, and I'm now connected as a different user. So I'll go up to Tools, into Interactive SQL, and I'm going to run the same query. So Mary Kelly had encryption at the column level for the salary column. So if I run this, then we can see that M. Kelly my new user does not have encryption privileges for the salary category, so it will return with my default of 0. When you encrypt data at the database and column level, you're still vulnerable to attacks over the transmission process. Now, to ensure that data is fully protected, InterBase has over-the-wire network encryption, or SSL network encryption. Over-the-wire encryption allows for the data as well as the commands to be encrypted between your server and clients. This is important if you're concerned about someone seeing the communication, an increasing concern as organizations become more dispersed geographically and allow access from unsecure networks. Data transmitted over the networks is susceptible to sniffing attacks and other malicious intentions. InterBase over-the-wire encryption consists of two parts. One part sits on the server and the other on the client side. InterBase uses OpenSSL to support the InterBase encryption. So InterBase embeds the OpenSSL libraries into the InterBase server and client to help them implement encryption-related features. InterBase uses these libraries as the basis for supporting database and column-level encryption functionality. Now, before setting up over-the-wire encryption on the server or the client side, you have to first obtain the necessary security certificates provided by a CA or a certificate authority. InterBase uses these certificates to verify the identity information, similar to how a web application that has a secure digital certificate, it's just a way for the web browser to authenticate that the web app that it's communicating with is actually the legitimate site and it's not a fake. I should also mention that the CA doesn't replace the username and password associated with a user, so you'll still have to use those. Over the wire requires that you generate two certificates, a public key certificate for the server and the server's private key and server certificate. You can use any SSL tools to generate these certificates, or you can contact your IT department or some CA vendor. To learn how to create SSL certificates using OpenSSL, you can check out their website at openssl.org or here at the bottom of the slide. Once you have your PEM files, you can walk through IB Console's over-the-wire wizard to complete your SSL network encryption. You'll see that it isn't too hard to initially set up InterBase's over-the-wire encryption. Add your port, client, and server certificates, and you're almost ready to go. For more information on setting up your server and client for over-the-wire encryption with OpenSSL, and to see some sample configurations that enable and implement over-the-wire encryption across the network, I recommend looking at our InterBase DocWiki, where you can find additional notes and links for InterBase's use of SSL encryption. We go through all the trouble of making sure, or at least hoping, that our databases are as secure as we can make them. But what happens to our backup files? A lot of the time, they may just be sitting there on a removable local disk, a shared network, or maybe in a data warehouse. No matter where they are, what happens if someone gets a hold of them? In most circumstances, they can easily go out and restore the file to a server where they have some permissions, and oh no, because all of that data we worked so hard to secure is now theirs. To maintain the confidentiality of your encrypted databases, you must create encrypted backup files. Encrypting your database backup files just means that you're taking the security protocols one step further. In InterBase, we have built into our GBAC functionality this database backup encryption. GBAC is a command line tool that's used to perform database backup and restores. And you have a few different options depending on your requirements. To perform an encrypted database backup or restoration using GBAC, here's an example of that code. Using -B for backup and -R for restore, you then can add the database location, the new name of your backup file, the system encryption password, the encrypt or decrypt switch, and the backup key password. The encrypting and decrypting process can also be handled with the InterBase GUI IB console by the database owner, and it also uses a visual wizard to walk you through step-by-step the database backup and restoration. With InterBase, it's very easy to set up these security measures. Here are the steps used to encrypt your database and the columns along with access privileges. So the first step is to ensure that the Embedded User Authentication, or EUA, is enabled on your selected database. This step is performed by your database owner, or sysdba. Then that same database owner will want to create your sysdso, your data security owner or officer. Steps 3 through 5, where you would create your SEP and encryption keys and grant the database owner with encryption privileges, are all performed by the security owner, not the database owner. Once your DSO has granted the encryption access, the database owner then has the ability to encrypt your database and the columns, and as well grant or revoke privileges to other users or roles based on your organization's access requirements. Staying up to date on database security and regulations provides you with peace of mind, and InterBase encryption with 256-bit AES built-in encryption provides secure data anywhere you go on any of your Windows, Mac, iOS, Android, and Linux devices. In terms of data security, most importantly, just remember to always encrypt your data from prying eyes. For more information on InterBase, check out the InterBase product page and our InterBase.wiki site, where you can find some sample SQL and additional in-depth info on securing the InterBase database. If you have any questions that you would like to email to me, please feel free to reach out at mary.kelly@embarcadero.com. Thank you.